All right, Integrated Math 3 students, we're going to get this final lesson for our Unit 3.1 where we've been dealing with rational expressions. We've solved equations with them, we've simplified them, and we're going to get to some arithmetic, some operations with them. So we're going to go ahead and get the lesson going. All right, so I'm going to have a little background music while we have our lesson. It's a simple little jazzy funk type music. So now that I'm have no face-to-face learners, I'm trying to find ways to add a little value to my recordings. So, all right, multiplying and dividing rational expressions. How many of you remember how to do this? When we say rational expressions, obviously we've discussed that means fractions, right? So here we have two fractions that are being multiplied. Here we have two fractions that are being divided, okay? So I want you to go ahead in your notes, write these out, and I want you to go ahead and try to solve them, okay? So I'm going to pause the video and it's going to say, go ahead and solve these two operations. Okay, so you've solved these. Let's see if you did it correctly. Now, what is the rule for multiplying fractions? Well, the rule for that is you multiply straight across. Okay, so I'm going to multiply the 1 and the 2, and the 2 and the 7. So we're going to get 2 over 14. Okay? Then the next thing you do is you need to simplify. So we've done a lot of practicing with simplifying. Okay? So simplify. 2 over 14, well, we know that's 1 over 7. Okay? So that's how we could do it. We could also have written this like this. 1 times 2 over 2 times 7, and what happens? Well, we cross through the 2's and we get that 1/7. So there's more than one way to do this, okay? Now what about division? Okay, how do we do division? Maybe you did it right, maybe you couldn't remember because it's been a while since you've done this. And one of the rules for this is keep, change, flip is the rule. Right? KCF. You probably had a teacher explain it this way back in the day. So what does that look like? Well, keep, change, flip. We keep the first one, we change the sign to multiplication, and we flip the second. So division for fractions is essentially just multiplication, like the first problem we had up above, right? So when we go to answer this, we're going to multiply straight across. So now we're going to multiply, which I'm not going to rewrite the steps. So we multiply just like we did up here, multiply straight across. 1 times 7 is 7, 2 times 2 is 4. Can this simplify? Because we would want to if we could. I like this music, yeah. All right, so 7/4 is what our answer is. Can we simplify that? No, we cannot. So this is the idea that we need to help us out today, okay? A lot of what we learned earlier in the week, simplifying, is going to come into play here. Okay, so let's draw a line in our notes here. Let me pull up. Oh goodness, no, I don't want that. I want solid line. Draw a line in our notes. Let's get to some of the iMath 3 examples that we want. So example 1. All right, let me go ahead and pull these up here. Let's see. Let's do this question here. So we have two rational expressions, 6x squared y cubed over 2x squared y squared. We're multiplying that by 10x cubed y to the 4th. And then we have 18 y squared. Okay. So again, the steps to this are going to be the same as up above. We're going to multiply straight across, and then we simplify. So multiply straight across on both of these. So we're going to get 60 x to the 5th y to the 7th. There we go. Hopefully that makes sense. Let's do the next one on the bottom. 2 times 18. That should be 36. Then we have x squared y to the 4th. Again, we're just multiplying those same variables together, and the powers get added together, okay? So now we want to simplify this. That's the last step. So multiply straight across, then simplify. Well, what is 60 over 36? Well, the GCF is 6, I think. So that's, oh, actually, it's more than that. What is it? It's going to be, what goes into both of these? 12? I think 12 goes into both. So 12 goes into both, so it's 5 over 3. What about these variables? X to the 5th over x to the 2nd. So we've learned about this prime factorization, but we know we can subtract these exponents. So that's going to be x to the 3rd. Here, y to the 7th over y to the 4th. We subtract those exponents, it's going to be y to the 3rd. This is actually going to be the answer to this problem. So those aren't so bad. Let's do a division example. So dividing. We're going to do one just like that. So 5pq over 16p cubed. Then we're going to divide, and then we're going to do 35 p squared q squared 8 q to the 5th. Okay, so we have a division problem, and we remember what we wrote up high is keep, change, flip. That's still going to remain the same. All we're doing now is just throwing more variables in this, making it a little more challenging, but not too bad. Like, if you did good on the simplifying, you should be fine here. So keep, change, flip. We're going to go ahead and do that. So keep the first one the same. Multiply. We're going to flip this. 8 over 35. P squared, Q squared, Q to the 5th. Oh, I have not flipped it. I messed up. Hold on. This music is, you know, got me in a special place here. So 8q to the 5th. P squared is on the bottom. P squared, Q squared. All right, we're good. Let's go ahead and do the multiplication, because that's what we need to do next. I'm going to write that over here. 5 times 8 is 40. P. Q times Q to the 5th is Q to the 6th. Okay, I am going to need to bust out a calculator for this one. So 16 times 35 is, whoa, 560. Wow. Let's go ahead and write that at the bottom. 560. We get P to the 5th, and then we get Q to the 2nd. Now it's time to simplify. 40 over 560. I wonder if 560 can be divided by 40. Seems likely, but we'll check it out. Okay, 14. So we know that 40 over 560 should be 1 over 14. P and P to the 5th. We subtract those exponents. We notice that there's going to be 4 P's left on the bottom, so P to the 4th. Here we subtract these. Q to the 6th over Q to the 2nd. We get Q to the 4th. This is going to be our answer right here. So that's a pretty straightforward methodology there to get those. Now, obviously, we can increase the difficulty on this, and that's what we're going to have to do for you to be successful on Delta Math, okay? So let's go to another example. We're going to write down some more steps, but let's do an example. Here's the next example, and we'll take our time working through this. So example 3, we have 4x to the 2nd minus 4x over 2x squared plus 4x minus 6. And then we have x, that's going to be multiplied by x squared plus x minus 6 over 4x squared plus 8x. Now, before you go rushing in and multiplying these like we did up here, just straight across, that's the idea. We're going to have to do that. But what are you going to have to do if you start multiplying these? Well, you're going to have to use the box method. And I'm going to go ahead and tell you, you should not use the box method on these problems. These problems do not work like what we have been working. Whenever you see you've got binomials and trinomials, we have to change our approach, okay? So let's write out some steps, okay? The first thing you would want to do if you're approaching a problem like this, okay, is you want to factor each numerator and denominator. Well, how do we do that? Well, let's list out our steps again. We have GCF. We have quadratic trinomials. We have difference of squares. And then we have the last one, which is grouping, which we're not seeing a lot of those in our problems, but that's okay. So if I'm looking at this, I'm going to go ahead and use my factoring toolkit to factor each one of these. So we're going to go ahead and start with top left. What can I do up here? We should be thinking, oh, there's a GCF of 4, so I'm going to go ahead and list that out. Take that out of there. What about the X? And remember, we always start with GCF, so let me make sure I write that again. You always want to start looking for a GCF. And we'll do that for all of them. We'll start that way. Let's go, so for X squared and X, I can take out an X as well, and that's going to leave me with X minus 1. Okay? What about on the denominator? Is there a GCF down here? Yeah, there actually is. It's a 2. So I get X squared plus 2x minus 3. Up top, we don't see a GCF. On the bottom, we actually do. We get 4x, and then inside the parentheses, we're gonna have x plus 2. I wrote writing that wrong. Now, since the numerator of this right fraction doesn't have a GCF, let's see what else we could do to it. Is it a quadratic? Is it difference of squares? Is it grouping? Well, it looks like it's a quadratic trinomial. So what adds to get 1 but multiplies to get -6? So we have 2 and it looks like 2 and 3, and the 2 needs to be negative. So I'm going to go ahead and write this: x minus 2, x plus 3. Now, if we can factor any more, we need to do that. And I'm looking around at these. The numerators seem factored to me. The denominator over here is factored to me, but here I have another trinomial. So we're going to rewrite this, and these problems you're going to be rewriting quite a bit until you get it completely factored out. So this is going to be rewritten as 2 binomials. So -3, what adds to get 2 but multiplies to get -3? Well, that'd be -1 and 3. So x minus 1, x plus 3. Multiplied by x minus 2, x plus 3, 4x, and then x plus 2. Now, here comes like the fun part of this, I guess. We are now going to, we're going to say, in quotations, multiply straight across. So we're not actually going to be doing any of the operations for multiplication, like box method, none of that. We don't need it. We don't need box method for this. What we've essentially done is we've pre-simplified these problems. So let's put a little bullet point here. We're going to create a single fraction and write out all the factors. I realize that my screen is blocking these notes. Here we go. Write out all the factors side by side on the top and bottom. So you might be wondering, where is the multiplication actually happening? Well, it happens in this step. So I'm going to write out 4x, x minus 1, x minus 2, x plus 3. That's all that is the top being multiplied. We don't need to use box method for this. This is what we have. Then on the bottom, I'm going to do 2 times 4x I'm going to move that 4x over, by the way. I want to put the numbers close to each other. Now, this could be an 8, but it's going to be helpful not to actually multiply any of this. The less you actually do any multiplication in this part, the easier it's going to be for you to simplify. All right, so we've got them all listed out. Now, 3. Simplify. Divide away common factors. Now, what we've done here is we have pre-factored. In the simplifying problems section, you had to do the factoring there and then divide away common factors. We've already done it to start the problem off, and we just wrote them all next to each other through like multiplication, like we should, and then we cross away those common factors. Okay, so what are the common factors? Well, these 4's are going to go away, and the x's, the x here, they're being separated by multiplication, so I can do that. The x minus 1 and the x minus 1, the x plus 3 and the x plus 3. Now this x minus 2 and this x plus 2, they don't cross, we don't divide those out. So we get our final answer here. It's x minus 2, 2 times x plus 2. You don't need to distribute this. This is our answer, okay? That's our answer. So that's the process you're going to take for multiplication. Let's do a quick division problem, and you'll notice that these pretty much work the exact same way. Let's go ahead and do. Let's do this example here. 2a cubed minus 12a squared. A squared minus 4a minus 12 divided by 24a squared minus 8a cubed. Dude, this is going to be a tricky one, actually. I don't... We're going to work it, though, but there will be some factoring trickery here, so just be prepared for that. Get your mind prepared. Okay, so we have a division problem. The first thing we need to do is keep, change, flip, and the second part is multiply. Well, we're not going to say multiply. We're going to say factor. I'm going to go ahead and write out all these steps, and we're going to simplify them. These are going to repeat what we did up high. Factor, multiply, simplify. So that's what we're trying to do in this ordering. First thing, keep, change, flip. 2a cubed minus 12a squared. So we're keeping the first fraction. We change the sign to multiplication, and we flip the second one. So maybe you're noticing how this power is a little bit different. We're gonna have to deal with that, and I'm not really excited about that example, but it's good information, especially for honor students to see that. Okay, next step 2, factor. All right, let's rewrite these factored. So up top here, there's a GCF. We're looking for GCFs first. Up top, 2a cubed minus 12a squared. Well, the GCF is 2, and then I can take out an a squared. So what's left inside of here? That's going to be a, and that's going to be minus 6. There we go. Is there a GCF up here? No, but it's a quadratic. So let's try to factor that. A squared, so we want, for 15, what adds to get negative 8, that multiplies to get 15. So that's got to be, what would that be? So 3 and 5, yep. 3 and 5, both negative, actually. So we want a minus 3, a minus 5. There we go. Then we're going to do the bottom. Is there a GCF on this denominator? No, it's just another quadratic. So we're going to have multiplies to get negative 12, adds to get negative 4. So that should be 2 and 6. The 6 is going to be negative. So it's a minus 6, a minus 2, or plus 2. All right, so now we get to this one, which I said is going to be a little bit tricky. So let's go ahead and start by writing out what we think the GCF is. Well, it's going to be 8, and it's going to be a squared. So 8a squared. And what that gets us is 3 minus a, which is actually not very helpful for us to get this in the right ordering. So I'm going to leave that there. We are going to rewrite the way that, let's go ahead and rewrite it, okay? So let's take a little sidebar over here. Let me go a little bit further to the right. So if I take 3 minus a, and I factor out a negative, it becomes negative 3 plus a, which can be written as negative a minus 3, which would actually be better for us because look up here, we have an a minus 3. So I said that this was going to be a little bit tricky. It's not too complicated, but it is something additional to keep in your mind. So I can rewrite this as this, and I'm going to take a whole step here just to rewrite it, and I'd like you to do that as well. So we're going to rewrite it like this: a minus 3, a minus 5. I'm going to pull out a negative, okay? And then that changes that to this, which is super helpful because look, now we've got a common factor up top. All right, next, multiply one fraction, 2a squared, a minus 6, a minus 3, and a minus 5. On the bottom, I'm going to move over this negative 8a squared. And I'm going to just write, I like to keep those numbers in the front. It's just easier to do that. And then a minus 3. We're going to cross through the common factors. First off, a squared, those are going to go away. A minus 6 and the a minus 3. These have to stay. What happens with the 2 over the negative 8? Well, that's going to become 1 over negative 4. So I'm going to write this like this: 1 times a minus 5 over negative 4 a plus 2, which of course could just be written like this. Not a huge difference, and I don't think Delta Math really cares if you did it that way, but this would be our final answer. So that's a pretty wild example there. There's a lot of factoring happening, but it's always going to follow these steps up here. You're going to, for division, keep, change, flip. We can't forget that. Then you want to factor, just like with the multiplication. Then you want to multiply straight across. You know, write all the factors side by side on top and bottom. And then you simplify by just crossing through things. So what I've done is I've added 2 more sections. Notice this. Now, before you start crying, it's only 5 problems each, so that's not bad. But it is something that I want us to practice. Let's look at this example here. This one is the level 1. This is sort of the easiest types of examples you'll get. So I'm going to work this at high speed, okay? High speed. So this is a division problem. So the first thing I'm doing is keep, change, flip. So keep, change, flip. Then the next step is to factor as much as possible. So we're going to go ahead and rewrite these factored. This is x minus 2, x minus 1. The top is a quadratic. It's going to be x plus 2, x minus 1. On the bottom, we're going to have x plus 2, x minus 2. Then we go to the third step, multiply straight across. We're going to write all of these out side by side. X minus 2, x plus 2, x minus 1. On the bottom, x minus 1, x plus 2, x minus 2. Something interesting is happening here. You don't see a lot of problems like this, but these are all going to cross out. I don't think I've ever seen an example that does this. So what does that mean the answer is? Is it 0? Is it 1? What is it? Well, since this is division, we know that it's going to be a 1, okay? That's crazy. I don't think I've ever worked an example teaching this where it ended up being 1 like that. That's pretty cool. Then you have, of course, multiplication. So all of these are going to work in a similar way. So for this one's just going to take a little bit less time. I'm going to work it too. So this is x plus 9. I'm looking for GCFs. I'm not seeing any. I think the level 1 isn't going to have any. So I'm going to go ahead and factor. This is x minus 1, x minus 6. Okay. On the bottom, we're going to have, so I need 54. What are the factors of 54? So that's 1 and 54. I always like to write these out just so that I have them in my head. 2 and, this is 27. Does 3 go into that? No, I don't. Oh, wait. 3 does go into it. 3 goes in 10, 18 times. Okay, I'm gonna need a little calculator help. Even me, the math teacher, needs a little help sometimes. 4 doesn't. 5 doesn't. The 6, I don't think so. 6 does, yeah. Okay, yeah, 2 and 3 go. Okay, so we want 6 and 9. That seems to be the answer we want, actually. We need -6, so it's x minus 6, x plus 9. Are all these going to 0? What the heck? Sorry, not 0, I meant 1, but it looks like these are all dividing to 1. It's kind of crazy. I mean, I don't know if that's going to be true the whole way through, but I'm going to look at some examples. I might get rid of it if it's doing that. This is going to be a 1 again. Let's look at all these questions. Okay, that one, this one does not. So don't bank on all of these becoming 1. That one did. That one did not. So some of these do, some of them don't. And then we go to the next level, which I'm not going to really work into these questions. It's the same thing. Okay, you're just having to do all the factoring that you need to. Let me do this one just because I want you to see an example where you have to deal with this square. The best way to do this, so we're going to go ahead and do GCF for the tops. So GCF is, we want 10, and that's going to be x squared minus 64. So this one does have a little bit more advanced factoring happening. We'll go ahead and factor the bottom here. 72, 9, and 8 should work. So that's x minus 8, x minus 9. Okay. Up top, we have an x squared getting factored out. So that's x squared minus 7x minus 18. I'm already seeing 2 and 9 on that. And then let's talk about this bottom one, 10. If it helps me, which I think it will, I can rewrite x plus 8 squared as x plus 8 and x plus 8. I think that's a useful thing to do for you all. Let's do, let's continue factoring because there's more that needs to happen here. Look at this. This is a difference of squares right here. So this is 10 times x plus 8, x minus 8. On the bottom, I get x minus 8 and x minus 9. Up top, I have x squared. Here, let's go ahead and factor out this. It's going to be it's a quadratic, so we get, I said, x minus 9, x plus 2. There we go. On the bottom, 10, x plus 8, x plus 8. So this is completely factored out, and that's what we want before we go to the next step. We're going to write everything on one fraction, so I'm going to do 10 times x squared times x plus 8 times x minus 8 times x minus 9. So yeah, these can get pretty wild, but I mean, there's nothing new that's being taught here. It's just you have to use all the factoring. So factoring is definitely a skill that you need to make sure you have a good grip on. This 10, I'm going to move it to the front. It's going to be multiplied by x minus 8, x minus 9, x plus 8, x plus 8. We're going to cross through the ones that are the same. So 10, x minus 8, we have an x plus 8. We're only going to get rid of one of them though. Okay, so don't mark both of them, just one for one. X minus 9, x minus 9. And what we're left with is x squared times x plus 2 over x plus 8. And this should be the correct answer. So let's go ahead and try that out. So x squared times x plus 2. Put a fraction in here. So x, we'll use the square, times x plus 2. And then we have x plus 8 on the bottom. Make sure that that is correct. X squared. Yeah, looks good to me. Submit. Take its time. Come on. All right, I'll pause the recording until it submits. Okay, we ended up getting it correct. All that nice work. Look, they did pretty much exactly what we did. They even rewrote it as x plus 8 twice, which is a good idea. Okay. Alrighty, that's going to conclude this video. It's been 30 minutes long, but make sure that you start working on this Delta math. This is going to be due, we're probably going to make it due Wednesday next week, okay? So I'll send that update in an email.